I presented BIP 448, which is a covenant BIP proposal composing of 3 different opcodes. The most important or relevant one of them is TEMPLATEHASH, which is a covenant opcode. Checksig from Stack, which is a very old opcode that has already been live on Liquid for a long time and has been proposed a long time ago. And internal key, which is a Taproot specific, really small opcode as well. Yeah, I think no one opposes Checksig from Stack. It's very an obvious opcode. Internal key is kind of more of an optimization than a functionality. So I'm definitely more or less neutral on it. It just saves block space. I think people care about that. But yeah, it's not really a very special opcode. CTV was specified around the same time that Taproot was specified, so it didn't have any of the Taproot specific things that existed to take into account. So we kind of went more or less back to the drawing board. Like if we want to do a template thing opcode, how would we design it right now? So the main difference is that we don't specify a custom hash function. We just reuse the machinery that Taproot introduced for the SIG hashes, and we just take some of the fields that the SIG hashes already pre-calculates, the SIG hash system already pre-calculates, and then just see which ones we want to pick and hash them together. So the main differences are that we don't hash script SIGs, because in Taproot you cannot have script SIGs. We do hash the annex, so there was no annex when CTV was specified, so they couldn't have made that decision. We decided to hash the annex because it's closer to what the SIG hashes do. So if you wanted to have a signature scheme, a rebindable signature scheme, using TEMPLATEHASH, it will be more compatible with other signature schemes like that we currently have. So you might have heard of L2 or Lightning Symmetry as well. This is an improvement of Lightning, sometimes called like a next generation or a V2 or something like that, which kind of totally redoes the Lightning transactioning protocol, so not the routing and all that, but like how the channel constructions actually work. And it has a few benefits. So one benefit is that there's no toxic state, so there's no state that you really need to keep. And if you don't, or if you keep it wrong, if you keep your state wrong with Lightning, if you mess up, you can very easily lose all your money because of the punishment system. And you also need to keep the state of all your past states of your channels. And with L2, you can just keep one state and it will just override the previous state. So you just keep one state, and also if you keep accidentally the wrong state, your counterparty can just fix your state and not take all your money, right? So there's no this toxic waste problem where you kind of need to make sure that you remove certain things when the channel updates and that you keep all the other parts alive. And I think this is the biggest difference. So it simplifies the Lightning protocol. The exits are a little bit nicer as well. Like you can just push your latest version, and if it doesn't happen to be the right one, someone else will just push a latest version. Okay, yeah, so in the ARC protocol evolution, there's kind of 2 pillars. So one is the creation of the VTXO tree, and the other is the forfeiting of your VTXOs, your old VTXOs for the new ones. So initially, the transaction tree construction was based on CTV, and we hoped that CTV would exist. Eventually we decided, okay, it will not exist, so we're going to emulate CTV by signing and doing a signing ceremony, which is a large interactive ceremony where users have to be online for at least several seconds, maybe minutes, and to do some signing stuff. So that can entirely be replaced with TEMPLATEHASH, with a covenant opcode, so that this interactivity is no longer required. So then on the other pillar, you have the forfeit mechanism. And originally the forfeit mechanism used connectors, and it requires the users to be online as well during the rounds so that they can sign their forfeits. We replaced that with what we call HARC. It's a hash-based forfeit mechanism where the user doesn't have to be online at the time of the round. They can just do their forfeit later on. We have that implemented right now, but using the co-signed round, so not with the covenant. So with TEMPLATEHASH, we could still keep the same forfeit mechanism, which means that the server can just unilaterally create the entire round, and then users can just show up later to do their swap, to trustlessly swap into the new round. And then a future version, the next generation that we're envisioning for the forfeit system is called ERC, where actually you can create a single forfeit transaction that can be, or multiple forfeit transactions that you can pre-sign that can be reused on multiple occasions into the future, so that the server can actually create your new VTXOs every month without you having to do any forfeit. And then a watchtower can actually check on your behalf whether the server is doing this, and as long as the server is creating the new VTXO in the right way, you you're kind of safe and you can always get your money back. And then if a watchtower just makes sure that this happens, you don't have to come online at all. And if the server doesn't, so if the server is bad, the watchtower can somehow like try to wake you up or like wake up your device, send you an email, maybe a phone call even, so that you can come online and do your exit. But this is only like in the emergency situation where the server is basically abandoning the arc. Like in this kind of situation, you're kind of trusting the watchtower to make sure that your money is being safeguarded. And if you trust the watchtower well, you can just sleep on your VTXOs forever, basically. But you need to be there, like every month the watchtower needs to check, and if the server doesn't do something, you need to come online and you need to actually exit, right? So yeah, whatever method the watchtower needs to wake you up, it could be an email, it could be just a notification. But even in that scenario, like you could also give your exit transactions to the watchtower and or pay the watchtower some money up front to say, hey, because the transactions are kind of public, so you can say, if the server doesn't do it, just do my exit, and here's some money for it. And then you could even like not come online at all. So that's kind of, once we have template hash and we have the first like simple hash-based forfeit, we could eventually build ERC and have perpetual refresh. Doesn't come with a lot of work. Like in my implementation that I have on our Bark implementation, it's literally just disabling hundreds of lines of code that you no longer need for the interactive process. So like, it's a no-brainer. Yeah, so what happens is the server will then just, like you can either ask the server like, hey, I want my new VTXO like 3 days before it expires, or if you don't say anything, the server will just give you a hard deadline and say like, okay, 6 months before, I'm just gonna do it, whatever you want, no matter whether you tell me or not. So then we create your new VTXO, but it's still like blocked somehow. And then when you come online, you basically you unblock it by forfeiting your old one so that you get basically access to it. So while the server creates the locked VTXO, you don't have to be there. So you can just not be doing anything, and then right before your VTXO is going to expire, you come online, you ask the server like, did you get my new one? It says, yeah, it's here, and then you do the swap, and then you get the new one, you can go back to sleep. I think it has a more likely path to consensus than more elaborate governance proposals. I just see that consensus is like growing. Like there's several different independent people building proof of concept. Someone's building lightning symmetry. I've built now template hash. Some other people have been thinking about other use cases. So we put them all together on GitHub under bib448.dev. And yeah, it seems that there's no more like large objection to the idea. Originally there was a lot of objection like, oh, but we want this, but we don't want this. Now it seems that everyone's like, okay, this is just objectively useful. It's not everything that we want, but it's something that a lot of people can use, so we should just do it. The only thing that often still gets mentioned is like, why not TX hash? Well, I mean, there's always like, why not? I think this is a good... Exactly, why not simplicity? So like, we thought a lot about stopping point, like where should we stop adding new things, and it seems that rebindable signatures as a primitive and next transaction commitment as a primitive, they're just independently useful things, and this proposal just achieves those two things. And we don't know yet, right? We don't know whether we will see more use of the rebindable signature functionality or the transaction commitment functionality. We don't know which one we should optimize for. It seems that our proposal is kind of almost optimal for both of them. So like it's as optimal as APO to do rebindable signatures, and it's just one weight unit less optimal than CTV to do commitment. So yeah, I don't know why. Maybe people also don't like the fact that, I mean, I think there's definitely a group of people that don't like that CTV was also trying to change legacy script and SegWit script. We decided to just only change TypeScript because this is like the mode that everyone should be using. It gives you better privacy. It gives you better like composability of your scripts. So like, we just focus on this newest script context. And the Taproot annex is a field that was introduced in Taproot to basically leave room for any future improvement that we cannot yet envision. It's basically a field that just exists. It's almost always empty, and you can use it to put stuff in there. And if you if you make a signature for your transaction, it will include a hash of the annex. So anything that goes in there is kind of committed to in your signature. But currently, there is no like formally specified use of the annex in Bitcoin worlds. It's been used by like NFT people to like stuff just random data in there that doesn't have any meaning. Which I understand many people find unfortunate. But the annex is basically just an upgrade field that we don't use yet. So when you think about should we include the annex or not in our template hash, you don't really know. Like no single proposal has been formalized that uses the annex. There are some ideas that are floating around, like, hey, we could do this with the annex, we could do that. I'm pretty confident none of those would actually break because of the way we interact with the annex. So I think we should be safe there. Before for 8.dev, you have the PRs there, the bibs, some proof of concepts, you have a bunch of links there. It's basically a GitHub project, so there's also like a repository that has the PR